So in this video, we're going to go over how bases respond to powers. And specifically, we're going to be looking at how negative bases respond to powers. So before we can do that, I just want to make sure that we fully understand what the anatomy of an exponential expression is. So let's get started. An exponential expression is just another word for a power. So these mean one and the same thing. These mean one and the same thing. That being said, a power or an exponential expression is made up of two pieces. It has the big number, which is called the base, and then it has the smaller number, which is called the exponent. So the base is what's repeatedly multiplied. The exponent tells us how many of those bases are repeatedly multiplied. And we've already had some experience with writing powers as products. A product is just using repeated multiplication. So if I wanted to write 3 squared as a product, I would simply write 3 times 3. And then if I wanted to evaluate that, I would simply write 9. So that is the language that we want to make sure we understand. An exponential expression, otherwise known as a power, an example would be 3 squared. The 3 is the base. The 2 is the exponent. The 3 is what is repeatedly multiplied in the product based on the number of times or the number of those that the exponent says, and then evaluating just means to find the value. So moving on from there, this is where I want to make sure that we spend a couple of quick minutes looking at how negative bases respond to powers. So a negative base is going to be clear because it's going to be wrapped in parentheses. There's going to be no doubt that the number being raised to a power is negative because that base is in parentheses. So if you look at this first example of the base of negative 2 to the fourth power, we should recognize that that is negative 2 times negative 2 times negative 2 times negative 2 one more time. And what that's going to give us, if we work our way through slowly, remembering our rules for negatives when multiplying, negative 2 times negative 2 we know is 4, times negative 2 gives me negative 8, times negative 2 one more time will give me 16. So that gives me positive 16. If we jump over to the next example, again a base of negative 2, but this time to the fifth power, we're going to have to write 5 of those negatives. So negative 2 times negative 2 times negative 2 times negative 2, but one more time, negative times negative 2 one more time. So we already knew that up to this point we had 16. And if we multiplied by negative 2 one more time, that's going to give us negative 32. So that should be revealing enough for us to understand how the switch gets turned on and off with a negative number being repeatedly multiplied. And essentially, if we're looking at a negative base with an even exponent, we're going to get a positive outcome. And if we're looking at a negative base to an odd exponent, we're going to get a negative outcome. So again, a negative base to an even power will give us something positive. A negative base to an odd power will give us something negative. So those are the rules you want to state here. So a negative base raised dot 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 to an even power will evaluate as positive, and to an odd power, we can simply say will evaluate, whoops, not while, will, oh no, will evaluate as negative. And I just want to go back and change this. Will evaluate as positive back up here. Okay, so that's really important to understand. So we have this idea of repeated multiplication that's either going to turn out to be positive or negative depending upon the value of the base. So last thing I want us to quickly consider, when you look at these are not the same, because in the first example, we have a base of -2, and I know that because it's in parentheses, and that is being repeatedly multiplied 4 times. Versus over here, we have to be really mindful of that sign. Remember, that's an oppositizer. And that says to oppositize. So that says oppositize. Oppositize, in this case, the value of +2 to the 4th power. So here we know we're going to get 16. Here we're going to get 16 to begin with, but to oppositize really means to multiply that further by -1. So by the time we are all done, we get -16. So these are not the same. So be very mindful about recognizing what the base is. The base in this first expression is a -2 because the -2 is fully wrapped in parentheses and raised to the 4th power. In the second expression, only the 2 is raised to the 4th power and then oppositized. So that's a really important thing that I want you to walk away with understanding. And you will be asked to practice that on the following Google form. Thanks.